So let's assume we have a simple neural network with two hidden layers, X and Y. We want to learn how to map input data and output value using the set of weights and biases. The architecture of a neural network can be represented as follows. So we can get this thing and write it as this thing. Alright, so this is like X equals to W1 into X plus B1, that is sigmoid, W2 into W1X plus B1 plus B2, where X is input data, W1 and B1 are weights and biases for first layer, W2 and B2 are weights and biases for the second layer, and sigmoid is the activation function in the case sigmoid. So in the case of forward propagation, we'll walk through each step forward propagation to understand how the data flows through the neural network. So input layer, we start by feeding the input data into X into the layer. So first layer applies the linear transformation to the data using the weights and biases using this thing. So Z1 equals to W1X plus B1, where W1 is matrix with shape NM and B1 is vector of shape N, comma X, N comma blank, and where X is a vector with shape M comma something and Z1 is vector with shape N comma something. So activation function is the first layer which applies activation function to the output layer of transformation. So that's our activation function. This is our activation function, where sigmoid is the sigmoid activation function, and the second layer is this thing Z2 with W2 plus A1 plus B2, where W2 is the matrix with shape Pn, B2 is vector with shape P comma something, then A1 vector with shape N comma something, and Z2 is vector with shape P comma something, and activation function again we're going to write. So that will go here. That is sigmoid, where sigmoid activation function is where sigmoid is the activation function, and where we're going to write the output of the network, which will be final thing Y. And to train our neural network, we need to compute derivatives of the loss function with respect to each weight and bias. So we'll use chain rule to compute these derivatives. So derivative of the sigmoid activation function with respect to input is going to be this thing, where X is input to sigmoid activation function. Using the chain rule, we can compute the derivative of Y with respect to each weight and the bias. So this thing can be there, and this thing can be there as well. So simplifying these expressions, we get, after that we get this thing as well. After that we get this thing as well. Let's get all these into the line. Okay, simplifying these equations, we'll get these things. Now, forward propagation involves feeding input data through each layer of neural network, applying transformation and activation functions at each step. We can compute mathematical derivatives using the chain rule to train our neural network. So the derivative of output Y with respect to each weight and bias will be essential to training neural network. So I hope that provides more detailed explanation and the whole thing about the neural network. So we're going to write some things now, and we're going to explore some things now. So just we have been through all these things. I think this covers almost everything. Yeah. So that's all for this one, and I hope to see you guys in the next one. Until then, keep hustling and grinding. Don't give up. Keep keep hustling.